Today we are going to be doing what is called trigonometry. Trigonometry. In trigonometry, there is an acronym. Here's the acronym, SOH, CAH, TOA. You say it, SOHCAHTOA. Here's what it stands for. All right, we spell this SIN, but we say sine. Sine of an angle is equal to its opposite side over the hypotenuse. Cosine of an angle is equal to the adjacent side of the triangle divided by the length of the hypotenuse. And the tangent of an angle is equal to the length of the opposite side divided by the length of the adjacent side. These are called trigonometry ratios. And you're going to use these trigonometry ratios today and tomorrow to find side lengths of right triangles. And then tomorrow you're going to use the inverse property of these ratios to find angle measures inside of triangles. Okay? So, does everybody see how this acronym works and where the letters are coming from? The S is sine, the O is the opposite, the H is hypotenuse. Sine equals opposite over hypotenuse. The cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. The letters of the acronym are the beginning letters of the ratio and the two sides that form that ratio. Here's how this works, okay? First thing that you're going to be doing in your assignment today is you're going to express each ratio as a fraction. And as a decimal. To the nearest hundredth. You're going to be given a triangle, so we're going to take this triangle right here. And it's triangle QRP. And we got side lengths of 15. $8 and $17. First thing they're asking for is sine of P. So the acronym was SOHCAHTOA. Sine of P. Sine equals opposite side over hypotenuse. So the sine of angle P, you look at angle P, which is right here. The side opposite of P is 15. The hypotenuse of this triangle is the 17. And then you take 15 and divide it by 17. You get 0.88. Tangent of P. Tangent, look at the ratio. Tangent equals opposite over adjacent. Tangent of P, opposite of P is 15. Adjacent to P is the 8. Then we take 15 and divide it by 8. 1.88. And now we need cosine of Q. Cosine is equal to the adjacent side over the hypotenuse. Here's angle Q. All right, adjacent means next to. So the side next to Q is the 15. The hypotenuse is 17. And we've already divided 15 by 17. We get our 0.88. Cosine of P. Cosine equals adjacent over hypotenuse. Angle P. Adjacent to angle P is the 8. The hypotenuse is 17. And 8 divided by 17 is 0.47. Sine of Q. Back to the acronym. Sine equals opposite side over hypotenuse. So here's angle Q. The side that is opposite of angle Q is the 8. The hypotenuse of the triangle is the 17. Something's wrong. Well, maybe not. 8 over 17, we just did it. That's 0.47 again. Tangent of Q. Tangent equals the opposite side over the adjacent side. Opposite of Q is the 8. Adjacent to the Q is the 15. And 8 over 15, 0.53. Now, those are the sine, cosine, and tangent ratios for angle P and for angle Q in this right triangle. If you're confused on where these numbers came from, right now would be the time to ask. Yes? Okay. The question was, how do you know which side to find? If we're looking at angle P right here, in relation to angle P, do you see how it has one angle next, or one side next to it and another side next to it? All right. But isn't this always the hypotenuse? So the side that's next to angle P that's not the hypotenuse is called the adjacent side. Then the side that is left is called the opposite side. If you could picture yourself standing inside that triangle with your back against P, and if you looked out into that triangle, the side opposite of you would be 15, wouldn't it? And then you would have two sides next to you. One is 8 and one is 17. But the hypotenuse is always the hypotenuse, isn't it? It's always the side across from the 90. So that makes the other side that's next to it or adjacent to it the adjacent side. Okay? Now, when you're looking at angle, when you're in here in angle Q, the hypotenuse is still the hypotenuse, isn't it? That doesn't change. But do you see how now this side in relation to angle Q would be the opposite side? The 8 is opposite of Q, but it is adjacent to P. And the 15 is adjacent to Q, but it is opposite of P. So the same number, this 15, is an opposite side and it's an adjacent side, but it depends on which angle you're looking at. So if I did another triangle here, don't write this down, just watch. If we're looking at angle A, this side here, or let's do this is the hypotenuse, isn't it? And in relation to angle A, here's the opposite. And here's the adjacent. Agreed? If this was the same triangle, and this was angle A, and this was angle B, this would be the hypotenuse. It's still the hypotenuse, right? But now, this side would be opposite of angle B, and this side would be adjacent to angle B. So it's all going to depend on if they're asking for sine, cosine, or tangent of angle B, or sine, cosine, or tangent of angle A. You will never write sine, cosine, or tangent of the 90-degree angle. The ratios don't work with the 90-degree angle because you know it's a 90-degree angle. Does that help? Okay. Yes. I don't think so. I don't think so. Okay, so that's how you write sine, cosine, and tangent ratios. And now we are going to use those ratios. Boy, they don't give you much practice. Okay, here we go. We jump right into find x to the nearest hundredth. Here's our triangle. It's a right triangle, and we have a 25-degree angle. We got a leg that's 18, and we got a leg that's x units long. Now, step one right here. You look at the problem, you identify the angle you're working with, the side they're asking for, and the other side. And in this case, in relation to this angle, aren't you dealing with the opposite side and the adjacent side? We're not working with the hypotenuse here, are we? All right, we're working with opposite and adjacent. So now watch. Opposite and adjacent. Which ratio deals with opposite and adjacent? Tan. Tan equals opposite over adjacent, doesn't it? So watch, you write this. You write tan of 25 because that's your angle measure. Tangent of 25 is equal to the opposite side, which is x, divided by the adjacent side, which is 18. There's your ratio. Now you take this tan 25, you put it over 1. And you solve this proportion, okay? You crisscross multiply. So look, you get 1 times x, which is x. And then you multiply tan 25 times 18. Now, in your calculator, do you see the sin, cos, and tan buttons? All right, the sin, cos, and tan buttons. Here's how you have to type this in. You have to type 25 tan first. 25 tan times 18 and hit equals. You should get 8.39. That is the length of the opposite side. Let's do another one. Let's take this triangle right here. Got another right triangle. All right, so the process. The process was to look at the problem, identify the angle that's given, the side we need, and the other side. So isn't this x the hypotenuse? And what would the 13 be? Very good. It's adjacent. Which ratio deals with adjacent and hypotenuse? Cosine equals adjacent over hypotenuse, doesn't it? Cosine equals adjacent over hypotenuse. So we do cosine 70 equals the adjacent side, which is 13, over the hypotenuse, which is the variable. Now, this becomes a two-step problem. Look at this proportion. We got to put this cosine 70 over 1 again. So we're going to do cosine 70 times x equals 1 times 13, which is 13. In order to get this x by itself, we got to divide both sides by cosine 70. On the left-hand side, the cosine 70s cancel out. You're left with just the x. Up till now, we haven't touched the calculator on this problem, right? So now your calculator operation is 13 divided by 70 and the cosine button and equal sign. 38.01. A little better understanding on that second problem? Let's do one more. What have we done? Cosine, we've done tan. So here we go. We're looking at the angle given and the two sides that we're working with. The 21, it's across from the 90, so it's got to be the hypotenuse. And the side that we're trying to find is opposite of the angle that we know the measure of. So here's our opposite. So which ratio is that? Sine 70. Check that. Sine 52, right? Sine 52 equals the opposite side, which is x, over the hypotenuse, which is 21. We're going to put the sine 52 over 1. And we're going to crisscross multiply again. So 1 times x is x. And on the right, we got sine 52 times 21. So our x is equal to 52 sine times 21. $16.55. Got it? All right. Your practice for today is going to be on page 573. And 574. One through 10. And then 22 to 33. All right. You e-learners, you got to give me a minute. I haven't uploaded this page yet. I apologize. It'll be uploaded within 5 minutes. You guys that are in class, you can either wait the 5 minutes for me to upload this page, or you can go in the back room and get a book and use the book. For right now, e-learners, if you don't have a question,